Okay, guys, let's see. Algebra 1, Section 8.5, Scientific Notation. Now, guys, I know that you've talked about scientific notation in 7th grade, and the reason that we're talking about it again is because we've dealt with negative exponents recently, and so, of course, that's going to play into scientific notation, especially for very small numbers, okay? So we have two examples up here. We've got 261,000, and then we have 0.0000000409. I don't even know what that is, but we'll figure it out in a minute, okay? Now, the reason we have scientific notation is because scientists are often working with huge numbers or very tiny numbers, and it's much easier to work with those numbers in scientific notation than it is to work with them with lots and lots of zeros. It's a way of sort of abbreviating that number, and we use it to the powers times the powers of 10. Okay, so there are a couple of things. One, it's always going to take the form, and I'll do this in blue. It's always going to take the form of a number times 10 to some power, okay? And I'll put a box here. Now, inside this first box right here, okay, that number has to be between 1 and 10. It can equal 1, but it can't equal 10, okay? So if it were 10, we need to move it one more time and let it equal 1. We always want it to be between 1 and a number less than 10, okay? And then we'll put the exponent up here, and the way we determine the exponent is how many times we had to move the decimal place in the number to make it between 1 and 10, okay? As this number gets smaller, this exponent gets bigger, okay? And we'll talk about that again in a moment. But let's look at 261,000. The decimal point is right here for the moment. We're going to move it 1, 2, 3. That's not far enough. That's 261. We need to keep moving it. 4. That's still not far enough. That's 26.1. And one more time. Now we've got 2.61 times 10 to some power. Now remember, we made the number smaller here. So to keep it in balance, we've got to make the exponent larger right here. Okay? So how many times did we move it? 1, 2, 3, 4, 5 times. So we're going to make this number 5. All right? So since 261,000 got smaller, the exponent of 10 got bigger. Okay? Now we do the same thing to the other side. I'll write my box. Okay? Times 10 to some power. Okay? But now I'm making this number bigger. Right? I have to make it between 1 and 10. So 1, 2, 3, 4, 5, 6, 7. All right? So it's 4.09. We know that. But since I made this number bigger, right, I made it 4.09, I need to make the exponent smaller. So that's a way to help me remember that it's going to be negative 7. All right? So I keep those numbers in balance. And that's the way we write in scientific notation, guys. And we're going to do some examples with that stuff. But it's pretty easy. And you'll be able to see how it's applied for scientists, how they use it to sort of simplify calculations. All right? Good job. Let's go ahead and look at example 1.